Okay, one of the things you're asked to do is multiply this out. And everybody did this correctly, it was very good. You got x times x plus 2 here, and then plus 4 times x plus 2. And then x times x is x squared, and x times 2 is 2x. You get 4x here, and 4 times 2 is 8. You add the 2x to the 4x, you get x squared plus 6x plus 8. And people got that very quickly, okay, for each of the examples. And now we want to see if we can factor this. Okay, now it looks a lot like this, but there's a difference. And if you think about it, you can kind of see maybe what to do, but let's just pretend we don't know any of this. Okay. We have several possibilities. Okay. Like it could be x plus 1 times x plus 8, maybe, because 1 times 8 gives us 8, and x times x gives us x squared. Now we'll see if the 1 times x and the x times 8 gives us a negative 6x, and it won't, but we can see that. But it could be x plus 1 times x plus 8 would give us the x squared, and it would give us the 8. Okay, so that would work. Minus 1 times minus 8 is 8. That works. Of course, 2 times 4 is 8, but that's exactly what we did. So, we know it's not going to be this because when we multiply this out, it doesn't give us this. Okay, but here we've got a minus 2 and a minus 4 is another possibility. Minus 2 times minus 4 would give us plus 8. All right, so which one of these, if any, works? Okay, well, everybody work this out and got it correct. This one didn't work. Now you can kind of look at this. Once you get used to the pattern, you can look and see, well, I'm going to have a 1 times x, and I'm going to have an x times 8, and that's going to give me 9x, right? So this gives me, I'll just write it small here, x squared plus 9x plus 8. That doesn't work. This gives me x squared minus 9x plus 8. So I'm getting the 8, but I'm not getting the right number here. I know I'm not going to get the right number here because we tried that one, or we did that one before. On this one, though, of course, we end up then with x squared minus 6x plus 8. And there it is. Okay. Let me give you another one. And I'll write it down here. Let's make it x squared minus 5x plus 36. Now, we can write down possibilities. And that's the way I like to start this process. So that would be like, maybe that could be x minus 1 and x plus 36. Okay. That's, oh, what, it should be a minus 36 over here, but a plus adding that one. Okay. Or x plus 1 times x minus 36. Or x minus 2 times x plus 18. Or x plus 2 times x minus 18. Now, there are a lot of possibilities. Okay, these are 2 of them. See if you can write out all possibilities. See if you can just list all the possibilities for getting a minus 36 here. Okay, Yeah, you just gotta have two numbers that multiply out to negative 36, so one of them's gotta be positive, the other will be negative. And you don't know which one should be positive, which one should be negative. Okay, now, here I've made a list, and I just start with one, because one goes into 36 times, right? So I know I could have a one and a 36, and I don't know which one should be positive or which one should be negative, although, you know, after you make a few of these lists, and as a matter of fact, in the process of making the list, most people saw, well, I'm not gonna have to write these out because I know they aren't gonna work, but this one might work, so I better write it out and check it out and all that shit. Okay, so and anyhow, just systematically, because we always want to be able to fall back on a systematic list, okay? We don't always want to rely on our ability to work it out mentally and stuff. So we want to start with the idea of a complete list of all the possibilities here. Okay, so, well, one divides 36 times. That's one way to get 36. A one and a 36, and they gotta have opposite sides because of the negative here. And then next number divides 36 is two, so you got 2 times 18, right? And we can do 2 times 18 this way or 2 times 18 this way with the negative on the 2 or the negative on the 18. And either of these will give us a negative 36. It's pretty clear that neither one of these is going to give us a 5x, okay? Or negative 5x. Well, the next number that divides 36 is 3. 3 times 12 is 36. So we do plus 3 minus 12 or minus 3 plus 12. Next one, 4 divides 36. I chose a number you could divide by a lot of different numbers. Okay, just to illustrate the process. Okay, so 4 times 9 is 36. We have a minus 4 and a plus 9, a plus 4 and a minus 9. And actually, we're almost done because the next number that divides 36 is 6. So we're going to have x plus 6 times x minus 6. Okay. So that's a possibility we might want to consider. And we might be able to dismiss that based on what a special product tells us, but maybe we don't think of that. And so we have it there as something that we definitely want to check out. We don't want to miss the possibility. Okay. Now, after 6, the next number that divides 36 is 9. And we've already used 9. Okay, so after we get to 6, we don't have to go any further. We don't have to list x plus 9 and x minus 4 again. We've already got it. Okay. Now, we can see pretty clearly that if we multiply this out, this would give us x squared plus x minus 36x plus, well, minus 36, which would be x squared minus 35x minus 36. And that's nowhere near getting us to negative 5. And it's because the 36 is so much bigger than the 1. Okay, so the x times negative 36 just overwhelms whatever 1 times x will give you. And you're not going to get a minus 5 out of that. And you can kind of reason similarly with 2. 18 is way too much bigger than 2. And even 12 and 3. 12 is too much bigger than 3. You could get like a negative 12x and a plus 3x would be a negative 9x. We're getting closer to negative 5x. But even people even said, pretty sure that one of these is going to work because the numbers look like they're going to work out. Okay. So that's good. You have that insight. You see that you're probably going to want one of these, and then you can pretty well determine it's going to be the one that has where the negative is bigger than the positive, because you're going to have to get a negative on the x. Okay, so I think we understand that. Now, if we don't, just multiply all these out. Pretty soon you're going to get tired of multiplying them out, and you're going to see why some things work and some things don't. Now, your book gives you rules. Yeah, okay, you can remember those rules, but you're more likely to to remember this scheme than you are to remember those rules. Okay? Until you've used this scheme several times and start understanding why the rules are what they are, then it starts to kind of make sense. Okay, so that's fine. But we conclude that this is the right one. So we can say that x minus 9 times x plus 4 equals, if you, and I'm not going to write out all the details. With all the distributive law, although you should continue doing that until you're really sure of it. You seem to be, everybody seems to be pretty well on top of the distributive law here. But make sure you stay that way. And there's our factorization. Okay. Okay, well, let's try another one. And list all the possibilities if you feel like it's a good idea. But if you see a way to omit some of those possibilities, because they're obviously not going to work, you can do that. List the possibilities that might work, okay? And you judge what to leave out and what not to leave out, but list at least a few possibilities. Okay, so we got x squared. Minus 14x plus 24. So list down some possibilities and play around with it a little bit. Okay. So to get 24, we have to have either 1 and 24 or -1 and -24, right? Or 2 and 12, -2, -12, 3 and 8, -3, -8, 4 and 6, -4, and -6. Now the divisors of 24, we start low with 1, and 2 goes into 24, and 3 goes into 24, and 4 goes into 24. And the next number that goes into 24 is 6, but we already got the 6 when we used 4. Okay, 4 times 6 is 24. So if we tried to go up to 6, we'd say, okay, 6 times 4 is, well, yeah, but we already used 6 and 4. So we kind of ignore all that. Okay, then, and we can kind of do this in our head. We might not even want to write these two down, okay? Because it's obvious we're going to either get a 25 or a -25 on the x. But if we have a 2 and a 12, you see we're going to get a 2x and a 12x, which is 14x, and that's pretty close to the -14. Well, the next possibility, we'd make them both negative and we get -14, so that we pretty quickly check this one out and we can discount all the rest of these. And of course, as you're going through and listing them, you can kind of test if you want to. Is this going to work? And is this not going to work? And pretty soon you get a feel for what is going to work. Okay, so I think we're in good shape on that. I will mention on today's, 24/03/20 assignment, I've posted a set of problems, okay, for practice. The way everybody here is going, you might not need them, but there are problems, and there are 20 problems to factor, okay? And then after posing those 20 problems, it gives you the solutions to 10 of them. Okay, so you can check solutions in every other problem. And you can kind of see how that works. Now, that also I've included cases like the third problem we had for today's quiz. So let's just work that out, see what lesson we can go on from this. We got 2x minus 3 times 3x plus 5. Okay, well, that would be 2x times 3x plus 5. And everybody got this. I'll do this rather quickly, but minus 3 then times 3x plus 5. And then we multiply this out, we get 6x squared plus 10x minus 9x minus 15. And that's going to be 6x squared plus x minus 15. Okay. Yeah. Okay. Now, if I gave you this one and asked you to factor it, it'd be a bit more complicated than this because you have different numbers in front of x, right? Okay, so if we try to do an exhaustive list of the ways this might be factored, well, 15 isn't too bad. 15 is divisible by 1 or 3 or 5. 6 is divisible by 1 or 2 or 3, okay? So if we tried to list the possibilities, that's 6x squared plus x minus 15. Complicated. One thing, we could have an x with something and a 6x with something, right? And then we have to put two numbers here that multiply out to negative 15. Or we could have 2x with something and 3x with something. And again, two numbers here that multiply out to negative 15. So we could start listing possibilities. We could say, okay, this could be x minus 1, 6x plus 15, x plus 1, 6x minus 15, or x plus 3. Well, let's do minus first. X minus, we'll get grotesque. X minus 3 times 6x plus 5, or x plus 3 times 6x minus 5. Now, that's it as far as what we can do with 15. It's either 1 times 15 or it's 3 times 5. One of those being negative, the other being positive. So there aren't that many possibilities. We do similarly over here, okay? We do 2x minus 1 and 3x plus 15. With 2x minus 15 times 3x plus 1, or 2x minus 3 times 3x plus 5, or 2x minus 5 times 3x plus 5. Plus, that's being systematic, that was not good. Okay, now let's make sure we got -1, 15, -15, 1, -3, 5, 3, -5. Those all multiply out to -15, and of course, 2x times 3x gives us our 6x squared. Okay. Over here, same thing, -1 and 15, 1 and -15, -3 and 5, 3 and -5. So, want to be careful in writing these out. Then you can test which one works. And you can sort of dismiss some of them, but it's a little more complicated. So that's how you would go about doing this by an exhaustive list. Okay, so what would your factorization do for this one? Okay, now we have 6x squared minus 9x minus 15. We focus on the 6 and the 15, and then we see if we get a -9 to pop out as a coefficient of x. So there are two ways we can get a 6x squared. We can get it with x and a 6x, or we can get it with a 2x and a 3x. Now, if we use x and 6x, we need to get -15. So we could do -1 plus 15. Or plus 1 and minus 15. But of course, then the 15 could go over here before it multiplies the 6x. So we could have x minus 15 times 6x plus 1, or x plus 15 times 6x minus 1. And those are just the possibilities using 15 and 1. So there are more possibilities than we might think. So give ourselves a little bit more room. We could now do x minus 3 and 6x plus 5, or x plus 3 and 6x minus 5, or we could do, let's do x minus 5 and 6x plus 3, and x plus 5 and 6x minus 3. So you see, we get a lot more possibilities than we might expect. Okay? Now, there's no guarantee any of these are going to work because you also have possibilities for 2x and 3x. So over here, we say, okay, well, we've got possibilities for 2x and 3x. And we could fill in all the same possibilities for the 15 with the 2x and the 3x. Well, we can start looking at what we get here. If we do x, the -1 times 6x is going to give us negative 16x. Sorry, negative 6x. And 15 times x is going to give us 15x. Turns out that this is going to be x squared minus 6x plus 15x minus 15. Okay, and that's going to give us a 9x. If we do this one, we're using opposite signs on the 1 and the 15. And this turns out to give us x squared plus 6x minus 15x minus 15, which is going to check out. So we just kind of luck out, and very early in the process, we happen to stumble on the right factorization. Okay, so this is it. Now, there's no reason to expect that it's going to happen that quickly. Usually you figure you're going to get at least a ways down here, and maybe you're going to have to go through all kinds of possibilities to get it. But in this case, we just shortcut it. Now, just to make sure we understand what the entire listing would look like, we have a -1 and a plus 15 here, or 2x plus 1 and 3x minus 15, or 2x minus 15 and 3x plus 1, or 2x plus 15 and 3x minus 1, and then 2x minus 3, 3x plus 5, 2x plus 3, 3x minus 5, 2x minus 5, 3x plus 3, 2x plus 5, 3x minus 3. And aren't we glad we stumbled upon the right solution quickly? Okay, now some of these could be easy to dismiss. 15 times 6x is going to give us like a negative 90x, and there's no way. Okay, so 15 times 6 just isn't going to cut it. But 3 times 6 is just 18, so it'll be a negative 18, and then a plus 5 be a negative 13. That's not a negative 9, but it's close enough that we need to check it out. Okay. Some of these we don't need much to check out. If we're using a bigger factor with the 6, if you multiply the bigger the two factors with the 6, it's probably going to get too big unless you got a pretty big number in here. So again, it's a matter of trial and error, but after a while you develop kind of an instinct for what might work and what won't. Okay. It can be a royal pain in the neck though, because there's no reason to expect anything is even going to factor. Okay. If this was a negative 10x, I doubt that any of these would work. Okay. And that just means if you had a negative 10x, that just wasn't going to factor. And the majority of trinomials that you actually encounter in practice don't factor. So I kind of question why we spend so much time teaching something that's not very practical. On the other hand, theoretically, and I'm big on theory, there's a lot of theory around it, and it's, I think, well worth doing. Okay, well, let's put this circuit up.